So we are now at the laboratory of Prax, and my friend David from our technical department will explain us how we perform the partial discharge test with this transformer.
So this is our partial discharge equipment. Here we have the partial discharge cabinet where we make the test. So here we place the parts, as you can see here. We connect the primary and the secondary side, separating it in order to make the test. Then here we have the control unit, which apply the voltage between the two isolated points, and then here we have the partial discharge measurement, where we measure the partial discharge flowing through the two isolated points. And here we have the software where we can see which are the measurements that we are making now of the partial discharge.
So this is the software that we use together with the partial discharge equipment to make the test. So this software allows us to make the test according to the different standards. Now we will use this test procedure for the 60664 standard. This standard consists of increasing the voltage up to 1.875 times the working voltage, then decrease it to 1.5 times the working voltage, and then in the last 5 seconds make the measurements. So the test is considered successful if there are no partial discharge in the last 5 seconds of the measurements. So as we are considering this component that should work at a maximum working voltage of 850 volts peak, so it means that the maximum voltage that could be between primary and secondary side would be 850 volts peak. This the voltage that we are defining here, it is defined in RMS current. So according to the conversion, the equivalent voltage would be 600 volts instead of the 850 volts peak. So here, if we multiply the 600 volts per 1.875, we would have 1.1 kilovolt, and then 1.5 per 600 volts, we will have the 900 volts. Okay, so now we will perform the test. So here we're increasing the voltage up to 1.875 times the working voltage, which is 1.13 volts. So here we can see that we are using RMS current for a sinusoidal waveform. So this is the reason why we are making this conversion. Then we reduce the voltage up to 1.5 times the working voltage, the 900 volts. So here we are waiting the 10 seconds to ensure that the partial discharge are stabilized. And then in these last 5 seconds, we are making the measurements of the partial discharge. So as you can see here, there is no any inception voltage because the maximum partial discharge would were below the 10 picocoulombs, and here is where we define the measurement voltage. Okay, so this part could assure a maximum working voltage between primary and secondary side of 850 volts. Now the second test would be the extinction voltage. So here basically we would like to see which is the real extinction voltage in order to see how far we are from the working voltage. So for this test, basically what we make is to increase the voltage until we have partial discharge. Once we are having partial discharge, we will wait some seconds, and then we will decrease the voltage until we have partial discharge below the 10 picocoulombs. So this voltage would be considered the extinction voltage and would be the maximum allowed voltage to work between primary and the secondary side. So now we will perform the test. So now here you can see how we are increasing the voltage, and then this voltage is increased until reaching more than 10 picocoulombs. So here you can see the partial discharge that we are measuring now. Then we wait around 10 seconds to stabilize the partial discharge, and then we continue reducing the voltage. So here you can see that the extinction voltage is 1 kilovolt, so it means that the maximum working voltage between primary and secondary side would be 1 kilovolt. So considering that this is RMS voltage, then the real maximum peak voltage between primary and secondary side would be 1.4 kilovolts.
So, David, as you showed, this transformer can withstand up to 1000 volt isolation value, RMS, over lifetime. Pretty impressive. Thank you for watching, and yeah, see you in our next episode where we will speak about flyback transformers. Bye.
I see you.